In this video, I'm going to describe the additions and enhancements to Statgraphics 19. The changes to Statgraphics 19 fall in two general areas. The first are changes to the UI, the user interface. The second are enhancements to the statistical procedures. The user interface changes include a new ribbon menu that replaces the old menu, a relocated quick access toolbar that allows you to quickly access commonly used procedures, modified tab dialog boxes that make options easier to select, a single pane option in the analysis windows that lets you switch from the standard multi-pane display to a report-style single pane, a dashboard for displaying tables and graphs with different types of alerts. In terms of procedural enhancements, we've added 15 new statistical procedures. We've also added enhancements to 40 existing procedures. The table headers, rows, and columns may now be modified using different colors and fonts. There's an optional transparent background when graphs are saved to other applications. You may save images to image files from the stat gallery in addition to normal analysis windows. We've also added an interface to Python for those of you who want to code some of your own routines. You're looking now at the main Statgraphics 19 window. The most obvious differences from previous versions are the replacement of the old menu and toolbar with a new ribbon menu and a quick access toolbar across the top. The main menu categories haven't changed too much, although there is a new home category where you go to set various system preferences, a time series category where we've consolidated all the routines for analyzing time series data, and an interfaces category with the interfaces to R and Python. Let me now go ahead and open a Statfolio that I've saved. If I select File, you'll see access to recent Statfolios, data files, and XML scripts. The Statfolio I want is called Demo 1. And what you'll see as soon as this particular Statfolio opens is one of the new features that's added to version 19, the dashboard. The dashboard lets you take graphs and tables from various statistical analyses and paste them in a window side by side. It'll automatically color the panes either green, yellow, or red, depending upon various statistics calculated in those procedures. You see, for example, on the left, I've plotted an X chart and an MR2 chart for a variable called resistivity. The panes are colored yellow because there's a runs rule violation. Had there been any points outside the 3 sigma limits, those panes would have appeared to be red. There is a red pane in the upper right here. It's the result of a process capability analysis. And based on this process capability analysis, the CPK is 0.86, and that's low enough for the pane to be colored red. You also see down here in the bottom right the new features for various tables. The table in this case has its row and column headers colored specially, and the column headers are also bold and in italics. If I switch back to one of the individual analyses that created the charts in that particular dashboard, you'll see that the options that used to be on the analysis toolbar will now be displayed on the ribbon bar. That makes it very easy to do things such as save images and image files, change the size of the text on the graph. Everything is right there in front of you. You don't have to go looking for a menu on the right mouse button, for example. Another important change in version 19 is the addition of a single pane mode to analysis windows. If you've used previous versions, you're accustomed to a multi-pane mode where each table and graph appears in a separate pane. There's now a switch button on the ribbon bar that will switch from that type of a layout to a report style layout where all tables and graphs are included in a single window. It's your choice and easy to switch between the two. Now let's turn to some of the procedural enhancements. One of the areas in which Statgraphics has always been very strong is in fitting distributions to data. Statgraphics version 18 offered 45 different probability distributions, which could be fit to data or used to generate random numbers. In version 19, we've added the Johnson family of distributions, which can match the skewness and kurtosis of any sample of data. We've also added zero-inflated Poisson and negative binomial distributions for situations where there are more zeros than you would expect from standard Poisson or negative binomial distributions. We've added the ability to fit mixtures of both univariate and bivariate normal distributions, which are distributions in which two or more normal distributions are used to describe a sample of data. Finally, we've added a procedure to deal with arbitrarily censored data, that is, data with any combination of left, right, and interval censoring. As an example, here's the output of the procedure used to fit the duration of eruptions of the Old Faithful geyser. It turns out that there are two distinct components: short eruptions and longer eruptions. The distribution fitting procedure here determines the means, the standard deviations, and the proportion of the eruptions that fall in each component. Version 19 also includes important additions in the areas of regression and the analysis of variance. There's a new quantile regression procedure for modeling the effect of multiple factors on the quantiles of a distribution. New procedures have also been added for situations where the dependent variable follows a zero-inflated Poisson or negative binomial distribution. You can now fit models for y versus x, where the relationship consists of two or more linear segments with different slopes. There's also a new procedure for analyzing a stability study. Such studies are run to help determine product shelf lives. In the area of analysis of variance, we've made it easier to specify interactions in high-order terms in the general linear models procedure. A new variable selection option handles both quantitative and categorical factors. Finally, a new gauge study procedure has been added to estimate measurement error using a GLM approach. This procedure deals with unbalanced data and can estimate the effect of additional factors beyond just operators and instruments. Here's an example of a linear regression involving two linear segments. The program determines the intercepts, the slopes, and the location at which the slope changes. For version 19, we've also added an interface to this Python scientific computing language. Python may be downloaded and installed free of charge. We provide tools for installing and configuring Python, for passing data back and forth, and for executing Python scripts and capturing the output in Statgraphics. We're also adding procedures which give direct access to functions in the scikit-learn library without leaving Statgraphics. One of the areas in which we've been doing a lot of work is machine learning. In version 18, we added classification and regression trees, which is a methodology based upon decision trees for predicting either categorical or quantitative variables. In version 19, we've added decision forests. Decision forests consist of many classification and regression trees. They are built using bootstrapping, and basically the final model is an average of all the trees that are grown in the forest. Also in version 19, we've added an interface to the Python scikit-learn procedure for doing k-means clustering. And in version 19.2, you'll see support for support vector machines. We've also added, as you might guess, a lot of other enhancements to version 19. In the case of data visualization, we've added Venn and Euler diagrams, 3 types of waterfall plots, and the ability to put an additional line on a bar chart. We've added a number of statistical tests, including equivalence tests for standard deviations, the Wald-Wolfowitz test for comparing 2 samples, and the modified Levene's tests for testing the homogeneity of variances. In the area of design of experiments, we've added alias optimal designs, and also the ability to augment existing designs by adding additional runs in an optimal fashion. I'm going to quickly demonstrate for you how we can augment an existing experimental design in an optimal way. Here you see a 19-run screening design constructed by the experimental design wizard. In the analysis, it fits a model by estimating main effects and second-order interactions. Suppose now I wanted to take this design and add some additional runs to estimate quadratic terms, things like temperature squared. In version 19, I can go to the experimental design wizard, press the Augment Design button, and you'll see a new option for adding additional runs in an optimal way. The Search Options button lets me specify the criteria I want to optimize: I efficiency, D efficiency, A efficiency, or G efficiency. The New Model button lets me specify a more complicated model than what's already been estimated. So, for example, I can tell it I'd like to estimate a quadratic model. If necessary, I could remove particular terms or ask it to estimate all of the quadratics. When I then press the Optimize button, it'll search for 10 additional runs, which will maximize the D efficiency of the design when added to the runs that have already been performed. I hope you've enjoyed this quick introduction to the additions and enhancements added to Statgraphics Centurion version 19. There are videos available to learn more about each of these new features. You'll find them at www.statgraphics.com/Centurion19.